Alright, let's take a look at question 6. Question 6 compared to question 5, it's slightly tougher. Alright, let's read the question. The tank with a rectangular base have vertical sides and height h. So this is a tank. And the height of the tank is h. Alright. Initially filled with water. Alright. Water leaks out from a hole. Water leaks out at a rate which at any instant is proportional to the square root of the depth. The question is guiding in a way because the question defines some variable for us, x and t. X is depth water, t seconds, or rather t after the leak start. Write down a DE connecting x and t. So the step 1 of identifying variables is made slightly easier for us, where we only want x and t at the end. You could say that, but you could say that it's also slightly tough because when you talk about water leaking out from a small hole, this water leaking out is at a rate of leaking out. It's something over d something dt. D something dt, but it's not x because x is just the height. When the water leaks out, we are talking about rate at which the volume decreases. So we must first define the variable. Let V be the volume of water at time t after the leak started. Alright. So step 2, we have to formulate, right? Formulate. How do we formulate? You are actually given that dv dt is proportional to root x because it is proportional to the square root of the depth of water. Proportional. That's why what we formulate. However, we got to look at it very carefully. Our formulated DE, it doesn't look too good. Why do I say it doesn't look too good? It has one variable, V. V is a variable, volume at any point in time because water decreases. So it's definitely a variable. T is a variable because as time passes. X is the height of water. It also is a variable. Not too good. We need two variables only. Usually we only dy dx, right? Equals something in terms of x or in terms of y. So something has got to be done about this V. Volume is the volume of water at any point after the leak started. Now, after the water is like that. After the leak happened, the height of water is actually x. Correct? Am I right to say that now volume is actually area of the rectangular base times height? Yes, volume is actually height. Volume is actually area times height of the water. So, actually, I'm talking about dAx dt. Now, it's proportional to root x is equal to, you may think, oh, okay, equals to k root x. Can, correct, not wrong. But water actually leaks out of the hole. So can I say dv dt here, dv dt, is it positive or negative? You must observe that it is actually negative. I write like that, and I make a note and say k is larger than 0. K is actually positive number. Then the most common question you will ask is, can I don't have the negative sign? I know my k is negative. I won't fault you, yes, if you manage to get the answer. But it will always be good if you can identify it right from the start, the restrictions in the constants. If it's always negative or always positive, it will help you along the way. That's all I can say. So, since A is a constant, where, okay, better define A, where A is the area of the rectangular base. Now, area of the rectangular base is a constant. Correct? It's a tank. At any point, no matter what is the height of the water at any point in time, the area is a constant. So because A is a constant, we can say A dx dt equals to minus k root x. Then the x dt equals to minus lambda root x, where lambda is actually equals to KOA. And lambda is positive. If k is a constant, a is a constant, k over a must be a constant. Now some of you may ask, I know, Mr. Wu, I arrive at that without actually going through all these dv, dt, everything. I know I reached there, I know. I don't think I can give you the credit here because it's not so obvious. What is given is dv, dt. It's quite obvious that what they are given is dv dt. How you see from dv dt all the way to dx dt, I'm not convinced whether you actually arrive there or is it just by luck. Got to show it. Alright? So, with that, then we can start to solve the d. Okay, we can start to solve the d. The question here, okay, this one we've done. That is the d. Alright? Now, next part of the question, you want to find the time elapsed before the tank becomes completely empty, which means you want to find when x equals to 0, what is my t? Correct? And you're given some conditions because you're given exactly half empty after 1 hour and on and on. So basically, after you find the d, just solve the d lah. Okay, so just solve the d. So this part is called solve the d. How do we solve? You multiply both sides, or rather divide both sides by square root x, negative. Yes? Then integrate. Then you have a, sorry, this is a minus half. Alright? Then you have a 2 root x equals to minus lambda t plus c. We will always, as much as possible, after we get integrating constant, we will try and solve for the integrating constant as much as we can. How do we solve it? Usually the initial condition will help us. Usually the initial condition will help us. What is the initial condition? If you read the question now, if your paper in front of you, you read the question now, in the first line, it says that the tank is initially filled with water. I repeat, you look at the question, it says that the tank is initially filled with water, which means when t equals to 0, this means initial condition, right? This is what we call the initial condition. Right? Your tank is filled with water, which is x is equals to h, because h is the height of the tank. So we can then say that 2 root h equals to c. And therefore, we can say a master equation now, 2 root x equals to minus lambda t plus 2 root h. Getting better, right? Now, next, we want to find the value of t when x is 0. Correct? When x is 0, what is the value of t? If you actually do that now, you realize that everything is in terms, your t will be in terms of lambda and h, which is not what we want. Yes, which is not what we want. There's still a bit of information that we have not used. The tank is exactly half empty after 1 hour. We have not made use of this condition. Let's use this condition now. Okay? When t is equals to 1, my x is actually h over 2. Okay? Substitute into this line. Yes. Then you get a 2 root h over 2 equals to, minus lambda t. Minus lambda plus 2 root h. Okay? Where t is 1. So suppose to make lambda the subject, you get 2 root h minus root 2 root h. That means lambda is 2 minus root 2 root h. Very useful now. If you found that lambda is in terms of h, now we short of one variable. Okay? Everything now is in terms of lambda here. So you get 2 root x equals to minus lambda t. Sorry, my lambda can go. Minus 2 minus root 2 root h t plus 2 root h. Finally, we want to find what is the value of t equals to what when x equals to 0. Therefore, you got left hand side is 0 equals to minus 2 minus root 2 root h t plus 2 root h. The root h goes. Yes. Then you get t equals to 2 over 2 minus root 2. That means when t equals to 2 over 2 minus root 2, which you can use GC to find that this is 3.4142. That means after 3.4142 hours, let's take a look now. After 3.4142 hours, the tank is completely empty. But let us focus. The question asks for the further time elapsed. What does further time elapsed means? Look, the tank is empty after 1 hour. Look, this is the tank. After 1 hour. After 1 hour, how many hours more further time before the tank becomes empty? So this is 0 hour. After 1 hour is like that. After how many more hours such that the tank becomes completely empty? Because from 0 hour you count until here is empty. From here to here is 3.4142. Therefore, from 1 hour to the 3.4142 is actually 2.41 hours. Easy, right? Further time elapsed equals to 3.4142 minus 1. You get 2.41. This is hours. Yes? All good?